Okay, so implicit differentiation is we want to treat x and y as two separate functions. So this first is x times y squared. So we're going to do product rule on this. We leave x alone, right? We take the derivative of 2y squared, which is 2y, but then we're going to finish it with dy dx. And then we add that to, now we leave y squared alone. We take the derivative of x, which is 1, and then we multiply that by dx dx, right? So everything's being done with respect to x. We do the next part, which is minus. So we're going to do the same type of thing. X cubed is by itself, right? 1 dy dx. And then we add that to y, and then 3x squared dx dx. Right, and that's going to equal 0 because the derivative of 6 is 0. This becomes a 1, right? And this becomes a 1, right? And we're going to get all the dy dx terms on one side, so we have 2xy dy dx, right? And then we're going to have this term, which is minus x cubed dy dx. And then on the other side, we get this is a negative that distributes, so we get 3x squared y minus y squared, right? And then we factor out the dy dx. We get 2xy minus x cubed equals 3x squared y minus y squared. And when we divide dy dx to get by its, or we divide by 2xy minus x cubed, we end up 3x squared y minus y squared over 2xy minus x cubed, and that's the answer to part A, right? In exactly the form that they want. Part B is a little bit more intense. So we have to find the points on the curve, and then we have to find the equation of the tangent line. So we have a little bit more to work with here. And so the first thing that we'll do is plug x equals 1 into the original equation, because then the y's that correspond to that would give us our coordinate pairs. So we're going to do 1 times y squared minus 1 cubed, which is just 1 times y equals 6. And we're going to have a quadratic. We have y squared minus y minus 6 is equal to 0. This factors into y minus 3, y plus 2 equals 0. And this gives us y equals 3 or y equals negative 2. So we have the 2 points are going to be 1 comma negative 2 and 1 comma 3. Now, so to find the slope at each of these points, because that's the first thing that we're going to do, we're going to use point slope form. So we're going to use the expression for the derivative. So we have this expression, dy dx equals all this, right? So we're going to use x, we're going to do the first point, x equals 1, y equals negative 2, right? And we get dy dx equals 3 times 1 times negative 2 minus, and this is negative 2 inside parentheses squared, right? We get 2 times 1 times negative 2 minus 1 cubed, and we solve this out. We get this negative 6 minus 4, right? So it's negative inside the parentheses, so that gets multiplied by itself. But we saw a minus on the outside. We have negative 4 minus 1. So we get negative 10 on top over negative 5. We get a slope of 2. And so when we plug into y minus y1 equals mx minus x1, we're going to use the point 1 comma negative 2. We get y plus 2 is equal to 2 as a slope, and then the point was x minus 1. And that's the equation that goes, of the tangent line that goes through the point 1 comma negative 2. So well, the next point we have is 1 comma 3. Right, so this is the second part. Let's go back to here. 1 comma 3, right? And our dy dx again is 3x squared y minus, what is that? Y squared. And the bottom is 2xy minus x cubed. Right, so the same thing as the other point, we're going to find the slope. Right, we get dy dx equals 3 times 1 squared is 1 times 3 minus 3 squared all over 2 times 1 times 3 minus 1 cubed. And this works out nicely because the top is 9 minus 9, which is equal to 0, 6 minus 1 on the bottom. So this tells us that this is a horizontal line, and the horizontal line has the form y equals a constant, which tells us that in this case y is equal to 3 at all points along the horizontal. And then finally in part C, we're asked to find the x-coordinate of every point where the tangent line is vertical. That means that in dy dx, we're just looking for where the denominator of this is equal to 0. So let's see, if we take where the tangent line is vertical. Okay, let's pause here. Alright, so we set the bottom equal to 0. We get 2xy minus x cubed equal to 0. And when we do this, we get a factor of x. And then 2y minus x squared equal to 0. So we know that one of the coordinates is when x is equal to 0. Like the vertical tangent will definitely... the tangent will be vertical. The other part's a little bit trickier. We get 2y minus x squared is equal to 0, which we can simplify down to y equals x squared over 2. If we plug back into our original expression of xy squared minus x cubed y equals 6, we can get x times x to the 4th over 4 minus x cubed times x squared over 2 equals 6. When we simplify this, we get negative x to the 5th over 4 is equal to 6. If we multiply by negative 4 on both sides, we get x to the 5th is equal to negative 24. And so our second x value is kind of unusual, but negative 24 to the 1/5, which gives us a value of negative 1.9,